Good afternoon, ladies and gentlemen. This is Mohammed Medhat, the Managing Director of Sustainable Green Energy Business Unit, Qurra Energy. We would like to welcome all of you. Thank you very much for your attendance for today. Our session will be in line with the Solutions Day. We are very proud, actually, to present our solutions for today and to conclude a couple of energy efficiency and waste energy reuse and utilization solutions. So let me first introduce the speakers of the panel for today. Dr. Hafiz Salmawi, one of the professor engineering for the energy and the former managing director of Egyptera. Dr. Sharif Diwani, ABA board member and advisor. Engineer Ayman Qurra, the founder and chairman of Qurra Energy. Dr. Muhammad Salah, the quality excellence and energy general manager of SEDBIC, one of the leading companies for refineries, for refinery application in oil and gas segment. And last but not the least, Engineer Ahmed Shireen, thank you very much for being there. The president or the chairman of the Chamber of Building and board member of the Federal and Egyptian Federal Industries. Thank you very much for being there. And one of the experts of the cement industry segments. And it's also good to have, nice to have you within there. Thank you very much, Engineer Ahmed. So, and also from Turboden. Turboden is one of the leading companies worldwide for the organic Rankine cycle technology and waste heat recovery applications. Marco Parezzi, thank you very much for being there. Our partner, the marketing director of Turboden, one of the group companies of Mitsubishi Heavy Industries. Also, it's good to have some expertise worldwide and best practices within such technology. So let me first start with Marco Parezzi for 10 minutes of presentation. Marco, please, about the organic Rankine cycle and the best practice of this technology for several solutions all over the globe.
Yes, thank you very much for the invitation. Good afternoon, everyone. I'm here also with you in Sharm el Sheikh, but in the Blue Pavilion. I'm the Institutional Affairs Director in Turboden, and I have been involved in European affairs since 20 years. So I'd like to share today my experience with the policy and in the energy sector at the European Commission. Next slide, please. Yes, the general framework in Europe is the European Green Deal, started in 28. European Green Deal is a package of policy which aims to set the European on the path to a green transition with the ultimate goal of reaching climate neutrality by 2030. Next slide, please. So the European Green Deal is a package of policy. The Fit for 55 is translate this ambition of the Green Deal into law. So it means to have regulatory law available for this purpose. Next slide, please. In principle, there are, have you seen a complexity of law related to the energy efficiency and renewable, but the Fit for 55 amend the existing, for example, Renewable Energy Directive, Energy Efficiency Directive, or Emission Trading System. These schemes, these directives are available to incentivize systems and to incentivize energy efficiency investment, like, for example, in cogeneration or waste recovery system. Next slide, please. This is the purpose of the Fit for 55. So, deliver the EU Green Deal and climate targets to 2030 and 2050, operating, as I told you, in the different directive already existing for industry, energy efficiency directive, renewable directive, so the deployment of the renewables in the market, energy emission trading systems, so the energy intensive industries, for example, and energy performance of buildings. Next slide, please. The relevant provision in this Fit for 55 package is resumed here, and you can see, for example, energy and infrastructure planning, a district heating approaches, a level playing field in the heating sector, enabling framework for waste heat. Waste heat will be very relevant in the European policy in order to be exploited for district heating and also waste heat recovery, for example, in industrial application, in energy intensive industries like steel, cement, glass, or the other. Next slide, please. How we can implement this kind of solution thanks to the Energy Efficiency Directive. Here you can check the most interesting article related to how to promote this investment in companies. Article 3, for example, is related to the energy efficiency first principle. So it means that member states have to implement principle taking care and taking into consideration the energy efficiency for all kind of investment for public money. But also, in my opinion, the other two articles, Article 11 in particular, are important for the industry because company with energy management system are subject to energy audit. So if the company are not setting a energy management system, they are obliged to do energy audit every 4 years. On the other side, company with energy management system in place are obliged to develop a project in order to improve the energy efficiency. Next slide, please. I'd like to show you this interesting project at European level that could be useful for future policy. This is a map of all the energy efficiency obligation scheme in place in Europe. To give you an idea, the Italian mechanism is in place since 2005. It is called White Certificate Scheme. So every industry, cement, glass, steel, that implement energy efficiency project could have some incentive scheme called white certificate. On the other side, you probably know the green certificate. Green certificate are for renewable energy investment. White certificate in Italy is setting for improve the energy efficiency in industry. For example, waste heat recovery is in this specific energy framework, or other countries is mapped here. So I suggest to check this in order to have a situation around Europe. Next slide, please. The other scheme is the emission trading scheme, and could be useful to see the article 10A. So the company is allowed into a energy emission trading system are as free allocation for the CO2 quotes. But if they implement project with the energy efficiency in order to reduce the consumption, they can have free allocation of CO2 for their portfolio. Next slide, please. This is a general framework for renewable energy directive, but in my opinion, the only things important is to mention that renewable waste heat recovery is mentioned as renewable in the red renewable energy directive scheme. So it means that waste heat recovery is comparable to other renewable solutions. Next slide, please. This is the last slide related to the other framework, regulatory framework called taxonomy. Taxonomy is a sort of classification. So it means if you are classified in the taxonomy, you are considered as sustainable. If you are not classified in the taxonomy, you are not considered sustainable. What does it mean? It means that public money or incentive scheme could be allowed to the project included in the taxonomy. The other project could be exploited, but without public money and without incentive. To give you an idea, cogeneration is included in this classification. Also, waste heat recovery is considered in this classification. So, for example, the waste heat recovery with ORC technology with our technology or the cogeneration in principle is considered sustainable and so could be applied for obtain, for example, money from development bank or incentive scheme at national level. More or less, that's all from my side. I don't know if you have a specific question related to this classification. I hope to share with you some useful information about our scheme in Europe. Thank you. Thank you, Corra, for your invitation and to allow me to share my experience in the energy sector.
Thank you very much, Marco, for the insightful presentation about the best practices in Europe for the several mechanisms for the encouragement of the energy efficiency applications in different disciplines. I would like just to shed more light about the technology of turbo the organic Rankine cycle. The organic Rankine cycle is one of the technologies that is already new technologies for the utilization of the waste heat or the low grade energy, because the organic Rankine cycle more or less is like the steam turbine or the normal Rankine cycle. But the beauty of the technology that it is use a specific fluid that can evaporate and condense in a very very low grade energy. So waste heat recovery, waste to energy, solar energy to deploy. So it's a turbo expander technology, skid mounted, that we can be utilized in different applications, again for the small medium to large scale as well, not only for the large scale. So one of the applications worldwide is geothermal as well. Turboden is one of the leading companies in Europe for the geothermal applications. We have gigawatts installed capacity all over the globe and specifically in Europe. So that's why we would like, or we today for the Solutions Day, to have some, insights from Turboden about the practice worldwide and specifically in Europe, in order to have the concept and how can we encourage the applications of such technologies in different disciplines of energy efficiency. Thank you very much, Mr. Marco, for your
Yes, sorry,
insight.
if I can add something that could be, in my
Please.
opinion, important related to the technology. This technology is similar, as you told, with the steam turbines, but this specific technology, ORC technology, doesn't need the consume of water. So you don't need water for the cooling system. So it means that some application, when there is a shortage of water, could be preferable to use ORC technology, like for example in waste heat recovery, in cement or in steel that we are realizing. More or less, we have realized 40 plants, waste heat recovery plants in different countries, recovering from glass, cement, or steel industry. And most of them, when there is a short of water, for example, in Turkey, I have in my mind some countries, these applications are without the consume of water. That could be useful also for the application in your country. Thank you very much for your time and for this opportunity.
Um, so back to the objective of this panel, we would like today to shed more light about the applications and how can we, as a solutions provider, to encourage such application on the ground. So this panel today will have technical perspective. We will go through some application that might have an potential in the market, and we do believe that we have great potential in several disciplines, as we will discuss with the speakers through the panel. Secondly, it will be from the financial and strategic perspective as well. We will also share our insights with our expertise. How can we provide some sort of support for such application in order to grow such business in Egypt? And finally, also some we will discuss some challenges or practical perspective on the ground in terms of the local markets demands, and how can we also overcome such challenges. As just to conclude, some recommendation, and we are ending today the COP27 event. So it's a good opportunity to share our insights, not only from the background or the technological perspective, but also from the practice on the ground. So if you allow me, we have also a couple of slides that I will skim through very, very quickly about the some localization for such application and technologies on the ground. How can we apply such technologies on the ground for specific industries and at the general concept as well. So next slide, please. Um, So overall, those are some concepts of energy efficiency and resource utilization applications that we do believe that we have a great opportunity and potential on the ground in the local market. First is the waste heat recovery, and we will touch base about the waste heat recovery application either for power generation, electrical power generation, or for thermal, or for both. Specifically for the cement industry, we will be glad to have the insights from engineer Ahmed Shireen as well from that perspective. Simply, waste heat recovery is to use the waste heat or the exhaust gases, the thermal energy wasted in such exhaust gases in different industries to generate useful energy, again, electrical or thermal or both. Waste to energy, also to utilize the solid and liquid waste to generate energy, cogeneration and trigeneration, which is the maximization from the fuel source and specifically the natural gas to generate electrical power, and in the same time steam or any other thermal application. So to get the benefit out of, or to maximize the benefit out of the natural gas resource, and directly and indirectly we save natural gas for the premises itself and globally for the country as well. Also, from the sustainable perspective of gas utilization, so we have, like for Innocent, we will share some insights with Dr. Muhammad Salah as well. For the oil and gas petrochemicals or refineries, how can we utilize the flare gas? The flare gas is such a gas that is already or continuously incinerated either on the oil well side, the upstream, what we call it, or the downstream in the refineries and the petrochemicals. So we can utilize it to generate power. We can also recover the products, which is already the gas itself. It's a rich gas full of LPG, naphtha. So we have quite rich resources that we can utilize on site. In parallel to that, the carbon capture, and we are very glad to have today from Mitsubishi Heavy side as well our expertise. One of the leading companies globally for carbon capture that to utilize the exhaust gas, the carbon monoxide, to recover it in order to be utilized for industries and other applications as well. It's a quite interesting application, and also we have a very good potential in Egypt specifically for the fertilizer application. Why? You use the carbon capture as a urea manufacturing facility, so you get it from the exhaust rather than generate the CO2 itself, which is also quite interesting application. Next slide, please. So to skim through the applications, the cogeneration, as we said, you have the gas on site. Next slide. We have the gas on site. If you see such Sankey diagram, rather than you burn the gas for a boiler or a specific application, you can use the gas to generate your own power and the waste heat from the generation facility to feed the boiler, for example, and to generate. And we'll give you some quite interesting examples. Next slide, please. This is one of the application. If you see here, this one of the plants, that's it's a cogeneration. Here over there is the natural gas generator, reciprocating generator set that could use the natural gas to generate power, and then the exhaust gas of the generator is operating absorption chiller to generate chilled water just from the waste heat. So instead you burn gas to generate one source of power, you have a couple of sources on the ground with the overall efficiency, which is the maximization of the utilization of the gas. Next slide. There's another application also, but for tri-generation actually. If you see here, there's one of the projects. Those are the generators also working with gas. For example, this is a plant working as a 30 megawatt, the installed capacity. The gas consumption here is not just to operate the generator first, and then the exhaust gas of the generator, recovery 16 tons of per hour steam for the just from the exhaust gas, and some portion of the steam is operating steam absorption chiller, and we generated chilled water as well. So we have from one source, we have now electricity, steam, and chilled water on the ground. Next slide. So Another application, which is the waste heat recovery. Next slide, please. The waste heat recovery, the concept is there. Or next slide, if we can go through this one of the application, which is the cement industry. This is a typical diagram of the cement industry. In the cement industry of the rotary kiln, which is the raw mill, and the rotary kiln, we use natural gas or any source of fuel, but we have the preheater and the air quenching cooler. Those are two spots of the waste heat that we can recover and then generate electrical power from this waste heat, which is typically available at site of any cement industry. So next slide. Also, not only from the large scale, we have also on the ground glass manufacturing facilities, which is smaller scale, couple of megawatts. This furnace also of the glass manufacturing facility, we can recover the waste heat from the exhaust gas to generate electrical power on site, maybe 200 kilowatts, 500 kilowatts, up to 30 megawatts. This is the turbo expander skid, which is quite plug and play, just to plug the waste heat and then you generate the power without any use of water, which is also one of the merits of such a technology. Zero water consumption is one of the also strategic benefit of such technology. Next slide. There's also another application for that. We are very glad and proud of this project. This is the first and the largest waste heat recovery of a gas boosting station. Belongs to Gasco in Dahshur zone. 30 megawatts is recovered from 4 gas trains, gas turbines actually. The gas turbines over there are working as a mechanical drive of the gas boosters. So instead of we install another gas booster that may burn the gas, we recover here the waste heat, generate 30 megawatts to operate 50% of the capacity. In addition to that capacity on the ground, zero energy consumption, zero water consumption, and 120,000 tons of carbon that can be shaved every year due to the waste heat recovery for that power generation. And we are very glad, as I said, and proud for that. The next year it will be in effective operation. It's already financed by the EBRD, and later on we can share some information about it. Also, we are very glad that we are the company that we are now design and build the first waste heat recovery for power generation to Heidelberg cement company. We recover more than from 30 to 50% of the electrical consumption for the facility just from the waste heat. So building that facility, we are now also not only from the technical and financial perspective, but we are shaving more than 40,000 tons per year carbon tonnage or carbon credit. Next slide. This next slide. So also the flare gas recovery. Next slide. As I mentioned, we can use the gas to generate power or the gas as a full recovery plant to recover all the products associated with the gas that are burned. Next slide, please. And one of the applications that we are very proud of, the first and integrated flare gas recovery project that is already running since 5 years ago in Ishpetko in Hurghada. Now we are stopping the flare, zero flare at site of an oil well, not just the flare to power, but we use the flare. We recover LPG, we recover naphtha, which is gasoline and kerosene, and then we use the gas after the recovery to generate or to operate electrical power facility that is already synchronized and load shared with the grid, and we feed this electrical power just from the flare gas. And now we are stopping diesel at site, stopping electrical power consumption from the grid, as well as stopping the flare or wasting the resources over there. Next slide, please. Those are the it's quite compact application, portable as well. It can be utilized on site for that site, and next years we can move it to another site as well. So the whole plant, even the generator set, are cabinet or plug and play application, which is also ease things in terms of construction. Next slide. Also, we have a similar application using the flare gas, but for gas lift. We injected this gas back again to the oil wells, which is depleted in order to increase the productivity of the wells. Still is an application to the process, but we get the benefit out of this flare gas on site. Next. Also, the waste to energy. Next slide. We can use the garbage, of course, industrial or municipal or whatever the type of garbage, quantity or quality. We can customize solution to use such solid and liquid waste to generate power. I will show you next slide one of the application as well. This is an incinerator that can incinerate 1 tons per hour and 100 liters solid waste, 100 liters liquid waste. We generate 7 megawatts from the waste heat recovery of such generator using the incinerator or the solid waste itself as a fuel consumption. Thank you very much for this for the paying attention to such couple of slides. The main message from this slide, I would like to welcome the panel. Please, the speakers share with us the panel in order to discuss a little bit further. Please, free seated, Dr. Sharifi. Thank you very much. دكتور حافظ الأول. طيب اوكي. So خلاص طيب دكتور حافظ تحب
This is much better. Uh, uh, I, yes, I might talk a little bit on a different topic, but it's for sure it's still related. It's an energy topic, but it's talk about energy transition and what's going on so far in the energy strategy of Egypt. Next. Actually, when we talk about energy transition, we talk about 3Ds, which is diversification, decarbonization, digitalization, but also we talk about electrification, which means that converting some sector to operate on electricity rather than being working on a liquid fuel or gas. Also sectors integration, as Marco mentioned, competitive energy markets, which is very much to improve and important to improve efficiency as well as reduce costs to consumer, and regional integration, innovation, which is like smart grids, and attracting private investment. This is actually the main topics for energy transition. Next. Actually, there is a need to update, as you know, there is a strategy, Egypt Strategy 2035, and there is a need to update this strategy up to 2040, but that update is not just limited to just extending the strategy, but also there is some new criteria happen, either supranational or national, or even there is some development in the national objectives, like Paris Agreement, which came after development technology, which reduced tremendously cost for renewable energy and equipment, and more integration between different markets. Next. This shows how the strategy is built. Actually, we use the Times Egypt model, which is a model which is being used for long-term planning, but as they usually say, energy decisions shouldn't left to energy people because it has an impact on the economy. So we need to test the run on a macroeconomic models in order to be sure what could be the impact of the energy strategy on the macroeconomics. So something like labor, poverty level, exchange rate, competitiveness of the subsidy for sure, which is relevant to it. But also, you need also to test on the short term because maybe some operational constraints of the plan might let you to achieve the target you planned on the longer term. Next, please. This is short-term runs, which is used as certain very famous software, which is called Plexus, which shows each plant, how it's coordinate and work together, and how the system could be stable under the high share of renewable, which I presented last day, 67%. So how system could be stable under this condition, and what operational criteria should be considered in order to assure the stability of the system. Next, please. This is an outcome which shows an asset management plan, which shows the blue line is practically, this is all the plants in Egypt, power generation plants. The blue line is for plants which continue working with us between 2020 up to 2040. The red, which we don't need it either because it's under efficiency or under capacity. And the black one is that which will be expired before 2040. So it's very much important to have such kind of an asset management plan to know what you will do with this substantial asset you have. Next, please. Now, there is some new technologies which is recently become very effective, like electric vehicle. Actually, a model has been developed for projecting electric vehicle, what could be the market, will how going to be evolved. This is a fully stochastic model in order to find out how the market will evolve. Next, please. This is shows how the market will evolve. It shows that for the reference scenario, which is scenario applying nowadays regulations, which exactly exemption from custom duties as well as reduced registration fees, we could reach 2.1 million car, including private and taxis, by 2040 if we applied a proactive measures like higher share of local manufacturing, low cost finance, to support finance, expiration, early expiration for cars, putting a limiting for 30 years, we might reach 3 million point two. This is shows how much gasoline we're going to save for the reference scenario, 2 million ton. For the proactive, it will reach 4 million ton. This is shows how much electricity will be needed for that. It's around 8 terawatt hour, and which is doesn't represent substantial. 8 terawatt hour for the reference scenario, just 2.5%, just to switch to 0.1 million car. And this is shows how much CO2 you will save, which is 6.7 million ton of CO2 as this, no, back please. 6.7 million ton, as well as for the proactive 10 million ton. And how many charging unit you need, it might reach 20,000 charging spots need for the proactive model. Next, please. This is the nexus between energy and water because, as you know, as we have a shortage of water, we do a lot of water recycling. We need substantial increase in our municipality water production and treatment. We need a lot of pumping because we have going to rely much on underground water, as well as we need water desalination. And this is, shows how much energy being consumed for each application of this. Next, please. Next. Where is it? The third technology, which is basically hydrogen supply chain. Actually, green, all of us hear now about green hydrogen, and this is, shows how green hydrogen could be used. Actually, hydrogen could be used as a feedstock or as it could be burned in engines, or could be used for fuel cells in transportation sector. So this is, shows the business chain of hydrogen, how we could apply hydrogen. But we should understand that hydrogen is an energy carrier, and hydrogen is a not prime source of energy because you use energy to produce hydrogen. Next, please. This is a kind of a curve which shows it's an average for projection for gas prices, how it's going to develop up to 2050. Actually, this is an average between all the gas hub around the world, which is a TTL-BP in Europe and Eastern Asia, as well as Henry Hub in the United States. It shows that the green hydrogen will go below the gray hydrogen by around 2030, and it will not go below natural gas before 2045. So this is very much important to understand how things market will be developed. Blue hydrogen has no chance because, as you see, it's a higher price. This is shows the cost of blue hydrogen. Next, please. This is shows how decision could be set in developing hydrogen plan. So basically, as you have primary source like nuclear, like renewable, like biomass, you could generate hydrogen. The prime application not to generate hydrogen, to use electricity for electrification, changing to electricity. If it is okay, that's okay. If it is not, you could export hydrogen, but hydrogen could be exported in three forms. One of them in hydrogen derivatives like ammonia or like methanol, or this is a derivative, or you can export hydrogen implicitly in products. So if you use hydrogen in cement industry, so practically you export hydrogen implicitly within the cement, if the exporter could accept the higher price, because this is, shows that the price is still high compared to the local market. Or if you have a pipeline, you could export hydrogen either in a blended form or as a pure, which is not available so far. But if you couldn't make electrification, then you will check if the hydrogen could be used for is lower cost than the gray hydrogen. If it's okay, you can go and check for transportation sector, use it for transportation sector or aviation and marine sector. So this is the first prime application. Also, you can export. If you have the hydrogen, then you check hydrogen which could be used in other industry as a feedstock in the industries, which is like ammonia production, I mean for local market, ammonia production, methanol production, iron and steel industry, and hydrocracking in the refineries. So you can use it if the prices of hydrogen become less than gray hydrogen. If it further goes that hydrogen goes below natural gas price, now we can use the hydrogen in other sectors to replace natural gas, and by that time you reach full decarbonization. All specs you can export all the time from if the price is still higher than the local market, but still acceptable by the international market, so you can export in that case. But this is still a big unknown. Next, please. In conclusion, I say that there is many drivers for energy transition, international and regional and national development necessitate to update the energy strategy. A long-term and short-term are very much needed to be complemented to each other. Otherwise, just focusing on long-term, it might not lead to inaccurate results. Energy strategy should be an integrated element in the national strategy. Couldn't do energy strategy away from the country social and economic strategy. Also, several new demand sectors are emerging, like fuel switching, like electric mobility, like water desalination, like demand for green hydrogen. Green hydrogen will not have a breakthrough before early 30 for gray hydrogen and after 2040 for natural gas. The main feature of energy strategy of Egypt include progressively high share of renewable energy, more electrification, more stability in the energy prices as a share of renewable energy becoming higher, higher regional integration, and less hydrocarbon dependency, and more friendly energy sector. Thank you.
Thank you very much, Dr. Hafiz. Please, you are kindly invited to share. So, back to the objective of this session. Again, we are very glad and proud that that Egypt has chosen Wafi as the slogan and objective of COP27 for this year. Wafi, it's all about the implementation. We have tried in the last couple of slides to show you that we have the technology perspective is there, the strategic and best practices all over the globe, and specifically in some certain countries that they took the lead to promote the renewable and energy efficiency applications are there. Right now, we would like to discuss with the panel the opportunities on the ground, and also would like to hear from the industries, the dynamics, the needs, the what you are looking for, and also we will discuss with Dr. Sharif and the Dr. Hafiz how can we, from the also the initiatives of the SDG and the NDCs of Egypt, how can we support such applications on the ground? What is going on as well from the financial perspective as supporting or access to finance funds in order to implement and to grow in such applications. So I would like first to start with Dr. Mohammed Salah. Thank you very much for coming and sharing your thoughts with us. Again, Dr. Muhammad Salah represents SIDBIC. SIDBIC is one of the leading companies in Egypt for refining and petrochemical applications. So, Dr. Muhammad, if you would like to shed more light about the industry, the energy efficiency opportunities or potential, and if you have also in mind some case study that we need or you would like to share with us about the upcoming applications, the opportunities, it will be very much appreciated.
Thank you, Mr. Muhammad. Actually, I'm used to be the last one to talk because the industry is where things happen. So we hear from all and then we give our reflections. But thank you for starting by me. In SEDBIC, we have already our decarbonization strategy and we have our responsibility. We respect our responsibility towards the SDGs and towards Egypt 2030 and so on. In our decarbonization strategy, we put our target to save around 18% in the next 5 years from our greenhouse gas emissions, but from scope 1, scope 2, and scope 3. The 18% from these three scopes actually equal or equivalent to more than 30% of the actual energy consumed in the plant. And this is a very challenging target. This target couldn't be achieved without new solutions, and we are on the solution days today. So we have to focus on the solutions. One of the existing identified solutions to be implemented in our plant is a new unit for the CHP. This CHP unit will generate around 7.5 megawatt in addition to around 50 ton per hour steam, replacing one of the existing boiler that generates the same amount of steam. That means we will use almost the same fuel gas to generate the required steam, and in addition, extra 7.5 megawatt, which is almost one third of our peak load in the plant. I think this is one of the very important solutions to be implemented. And but the main point, when we started to this, when we identified this solution and how this is a main issue, because we started implementing energy management system almost 10 years ago. And we have already in our company a very mature energy management system in compliance with ISO 50001. And this energy management system was making us able to identify a lot of and working on a lot of low cost and no cost opportunities during these 10 years. And according to this, we find that we need more to get our challenging and ambitious targets. And this is why we hired a high reputable international consultant, which is KBC. And this international consultant delivered a comprehensive roadmap. And this roadmap, including some medium cost and the high capex cost project, this is a CHP unit. And actually, all of this couldn't be done without a bold decision to invest in the energy efficiency field. This is one of, in brief, our story. And regarding the other technologies, I just want to highlight only one technology that is, I feel that from the industry perspective, will be very good if we find new technology to implement. This is the SHIP, the solar heating for industrial processes, because I think that the renewable energy in industry couldn't be in just the regular renewable solar cells to generate electricity, but solar cells to generate heat. This will be, I think, in my perspective, this will be the good solution if we can find and new technologies.
Definitely.
Thank you.
Thanks for your input. I would like to recap. Sedbek is the career petrochemical facility. So this type of process is normally in need for electrical power and steam. What I would like to highlight is what we say CHP, or the combined heat and power application. The concept that Dr. Muhammad Salah has already explained is to use the gas. Such amount of steam is almost consuming 4,000 tons per hour natural
Yeah.
gas. So instead of using this gas just to burn it in a boiler and generate steam, or one of the application is the combined heat and power. So you generate your electricity, and then the waste heat from the facility can generate your own steam consumption. That's why this one of the main application for CHP or cogeneration that we would like also to highlight. Also, the solar heating. I would like to redirect this question to Dr. Hafiz to give us a little bit more explanation about the solar heating as well, because normally, Dr. Hafiz, we are talking about solar PV. So we use the photon part of the electrical or to electrical power generate, but we forget about the solar heating or the solar thermal, the energy, the thermal energy in the solar power. So, if you would like also to share your insights to comment on the solar heating and preheating for industrial application, uh, I would like to add the question also to that about the area, because always the solar energy applications we are talking about the area. So, do we have any major difference of the space consumption or utilization meter square per kilowatt for solar PV and for solar heating, whatever the technology is? So if you'd like also to share your insights and comment for that, it will be much more appreciated. Thank you.
Thank you very much. But before answering your question, I just would like to mention some rule of thumbs usually there. First, energy efficiency is first, because energy efficiency is the cheapest resource of energy. Practically, it's not justified to generate energy and then waste it. So, energy efficiency is the first. Also, cost for saving 1 kilowatt hour or 1 kilojoule of energy is 1 to 7 or 1 to 14 in some cases compared to cost of generating this kilowatt hour. So by default, whenever there is an energy efficiency possibility, we should go for it before thinking about any solution to add to generate capacity. So this is number one. Regarding industrial solar heating, there is a lot of application. There is for medium, low temperature application, which is like solar panel or a vacuum tubes, or you might go much further for parabolic trough for application. Usually, it needs a large space in order to install a certain application. So it depends on space availability in the facility. But I believe we shouldn't uh, develop things as a way it's being developed before. Yani we don't think about I need something to generate steam. Actually, you might have wind turbine somewhere in the Red Sea, in the Western Desert. You have electricity, could operate an electrical boiler using renewable energy. It could be done without the need, and still it's renewable energy. So it depends on space availability. It depends. So it's a very much site specific, but as a general solution, you could have it. And as maybe mentioned in the previous presentation about guarantee of origin certificate, which shows that the electricity which is coming from the grid is renewable. So there is no problem. So heating anyway could be done inside using solar if you have sufficient space, concentrated tower, parabolic trough, collectors, but it depends on the space and site condition, because if you have a lot of dust, it might be a problem, also site constraint. Or you might have a different solution. You might have a very far renewable energy facility, generate, transmit it to the grid, and you operate an electrical boiler. It could be done.
Thank you for this, for bringing up this subject, because uh, the majority of us always thinking about the on-site application or whatever the solution is. So the main message to the all of us that right now we have on-site and we have in the in Egypt and on the different domains that we can use our grid, electrical grid, and also the natural gas grid as well, to having the or to overcome the issues or the challenges of the area or the feasibility, as explained by Dr. Hafez. Thank you very much for this input. And also, we would like to hear from you, Engineer Ahmed Shireen, about the industry of. We see that cement industry is one of the intensive energy consumers within the spectrum or the application that we have in Egypt. And of course, we have the initiative to encourage much more industries, local fabrication, local manufacturing, and that the building or any cement, steel, or any other type of such industries are the core of the business, the core of the industries and the construction for the upcoming plants. So the question is the energy consumption. And here I would like to address the energy for your industry as an expertise in the cement industry, not only from the electrical perspective, the electrical and thermal as well. So if you'd like also to share your insights and touch the base about what is coming, what is the upcoming plans and potential our future plans for such industry for energy efficiency and any other application for resource utilization.
Thank you very much, Mr. Muhammad. First of all, I would like to give you an idea about an idea about the cement industry globally and its directions. The cement industry is known, as everybody knows, is one of the highest carbon emissions in the world. It represents about 7 or 8% of the emissions. And in the industry, we are all very much concerned about this, and we are looking forward to participate and support and maybe accelerate the direction towards the net zero objective, strategic objective of 2050, with respect also to the milestone of 2030. Looking at the bright side, we are finally in Egypt currently started to be focused and concerned also about catching up with what the global cement industry is heading to. So we have created our own roadmap towards the net zero. This roadmap it consists of a few pillars. Basically, the main part is related to creating different types of cement. This is maybe not the topic of the discussion of today, but creating different types of cement, and this will um, um, lead to using less fuel in producing cement. But the most important part that we are talking about and related to is using different fuels and generate green energy. And this basically depends on using RDF and RDF feeding systems. And finally, probably the first time I've heard about waste heat recovery, that was like about maybe 6 or 7 years. The waste heat recovery technology is finally introduced to Egypt, and we have to admit that multinational companies and international companies took the lead in introducing such technologies, and it really makes me very proud that one of the Egyptian energy companies is the one that is implementing this technology, which is your esteemed company. I believe that very soon we will hear other. I know in the pipeline that there are lots of other producers of cement in Egypt are really planning to start implementing the waste heat recovery technology, plus even the solar energy generation. And we are currently discussing this with the government and environment ministry and all the stakeholders in order to start accelerate. We need to present as an industry that we are really willing and seriously concerned about the climate and the green future.
So just to elaborate a little bit about the energy mix of a certain manufacturing facility. I mean, in terms of the thermal energy and electrical energy, for a cement industry, the availability of power or availability of energy, thermal or electrical, this we would like to hear from you, because some solution is related from the electrical, as you have already mentioned, electrical perspective, waste heat recovery, renewable energies are there. And linking that with your message, Dr. Hafiz, that it's not bounded by the site itself. It can be generated remotely, and we use the wheeling mechanism through the grid or something. From the thermal perspective, which is the alternative fuel, is there any also development from the manufacturing itself for better utilization or the amount of gas per ton clinker? Is there any plans also to reduce that little bit, whatever the fuel is, coal or natural gas? What is going on from the cement industry as well to reduce a little bit also the fuel consumption from that perspective?
First of all, I just need to highlight that I'm not from a technical background. However, what you mentioned is really very seriously considered in the industry now that there are not only environmental challenges, but there are also lots of other financial, even challenges, starting from that most of the fuel, it's either like the steam coal, which is imported, and that's very big cost that the industry has to bear, or the other alternatives like the gas, which is the priority of the Egyptian government is to export. Mazot is also the HFO is also very expensive. So any saving in fuel is very much appreciated. It's also important to highlight that one of the challenges in our roadmap is how to provide financial support from all the different concerned institutions, financial institutions, and also in order to provide different solutions, because it's very costly also to implement even waste heat recovery, even solar energy, any solution, the RDF feeding systems. All of that will require lots of investment, and we need to speed up with implementing this. And that's why we're discussing with all the different institutions how can they help us and support us, also with respect to the instability of the Egyptian currency and its challenges with the LC issues. There are lots of financial issues that we're currently trying to discuss with the different stakeholders.
Like just to recap on what Mark already mentioned about the Green Deal.
شغال.
Okay, شغال. Okay. What Marco mentioned about the Green Deal include what we call it the CBAM, carbon border adjustment mechanism. Actually, Egypt one of the exporter of cement to EU. According to the CBAM, starting 2025, they will start to impose tax based on the carbon footprint on the products. So we might lose that market unless we have very aggressive energy efficiency and reduce carbon footprint of our industry. We might lose some of our European market for cement. So this has become more
mandate.
necessity, and this will spread. It will
Yeah.
not just be limited to Europe. It will be goes across the world. So Europe is just a start. So this is very much important.
Yeah. Thank you for this. Also to highlight this input, because we will share your insights with Dr. Sharif. And this is exactly what we need to match make between the industry and the financial perspective as well, or the platforms that are already there to support the industry to grow in that direction. So it's a pull and push strategy. So yes, we have the incentive to increase or to support the industry to implement on the ground, and on the other hand as well, as you have already mentioned, Dr. Hafiz, it is becomes a mandate in order not to lose the market that you export, or you have an accessibility somehow to that. So the question is right now, Dr. Sharif, about what is going on for the carbon and the trading and the trade-off for renewable energies and energy efficiency, the support from the financial perspective, the government, how the government is looking for the industries and how to promote such solutions for the current and the on a medium term plans.
Thank you very much, Mohammed. Dr. Hafiz, I have something to share with you. In the finance and economics world, we always say economic decisions are too important to be left to economists, not to no. On the contrary, we need the technology and engineering. And what I heard today is actually confirming that this is a very good way of thinking. We cannot leave economic decisions to economists. We have to involve technology and industry, especially technology providers and innovation, because that makes the economics of everything change depending on the technology. And I've seen a number of examples from you and from the gentleman from the other side of the zone. Yeah, that confirms this thinking. And it seems that also it's becoming very apparent, and we already see that in the solar field, for example, that the speed of the economics of the industry of solar generation has evolved dramatically, that it has become much more competitive, and it can become a source of energy in a very reliable way. So is wind as well, as the example you gave. I heard today very interesting solutions that you presented, and we heard about being used by the Egyptian industry. And when I'm listening to this, I'm thinking about the economics, because most of the cases we hear, especially in your industry, in the cement industry, it is quite expensive to do reductions. It's extremely, it's not, the economics are not correct yet. So you are the most challenged industry in the world to try to achieve and to catch up with this change of policy, that trade and taxation will impact your market share. So there are solutions. I mean, to answer your questions, Mohammed, there are solutions in the finance world. We have very proud to say that I shared today with Engineer Ayman Korra the launch of the first fund, the direct investment fund in Egypt, that does investments in offsetting, the carbon offsetting, which will allow companies like the cement industry. We are already actually in discussion with one of your competitors, but I think everybody is going to have, a lot to. Yeah. Are you not the Swiss cement? Oh, I'm sorry. So one of your members then. Yeah, one of your, very good. Maybe you can introduce me to the rest. Yeah. But that's exactly the point. We'll have to look at the technology, how it is evolving. I was fascinated to hear about carbon capture And it's also quite a very important technology that, to my understanding, the economics of it is still not very attractive. So this is where funds like ours come in. We've already had discussions with Cora Energy. We're extremely impressed by what they do, and we are going to invest with them to be able to make the economics of these investments viable, to allow the industries here to be able to invest in cogeneration, trigeneration, reduction, heat recovery, all these things. Sometimes, as far as I understand from you, it requires a little bit of private subsidy, if you may, which we will be able to provide. And the model, very simply speaking, I can now speak about it freely because it's public, is that we invest with companies like Cora Energy to finance what the gap that is missing in the capex, in the capital investment cost, sometimes in OpEx as well, to allow the investment to become economically attractive for the client and for Cora Energy. And because we achieve reductions in emissions or avoidance in emissions in some cases, there is economic value for this, which we claim in return. We don't take the money back, we take the carbon credits. And we then give it to companies like the cement companies that are in need for that. This gentleman I'm referring to was here earlier last week in COP27 when he heard about our initiative. He said, Sharif, we are great friends, but you're going to cost me a lot of money. I said, no, we'll try to make you a good deal. So I think cement industry is going to be a very big client for that type of carbon credits. And the other part of the equation, Mohammed, which is quite important, is regarding something you mentioned, the moving to electric vehicles, for example. What we don't have enough understanding in the other stakeholders. We had discussions in the Green Transformation Partners where Engineer Ayman is a member, and another member of ours from the tourism industry. They have buses that they're going to retrofit to make into electric. The diesel is still a subsidized fuel. When you look at the trade policy of the government and the duty exemptions, it does not address this problem because they are giving exemptions to electric vehicles that are coming already electrified. And then we have a huge stock of vehicles in the country that are emitting and consuming diesel that is costing the budget enormous amounts of money. Your graphs were fantastic. I mean, Ayman and I were looking at them and I said, we need to share these with our group because this is really going to be an eye-opener for them. So the economic side of it is that we have to demonstrate that the cost to the government, to the budget, to our budget as a country, needs to be taken into account because when you to reflect that on the trade policy and on the exemption policies of duties and so on, so that we can allow the economics to work and these vehicle retrofitting to actually scale up in a way that actually is good for the country. We have, and I'm sure all of you would agree, that the amount of urban pollution we all suffer in our cities is really in need of such a push going forward. I think I'll stop at that because there's a lot of it to discuss, but I want to tell you, I learned a lot today from these presentations. I'm really very grateful for inviting me. It's a very, very informative discussion, and especially Dr. Hafiz, I think we should be in touch to continue our conversation. Thank you, Hamad.
We are always glad to have you have the expertise in different disciplines to support our initiatives in the market. But before we end this part of the discussion, we would like also to touch base about the stock market for the carbon credits and the upcoming mechanism locally here. I'm talking, of course, worldwide. There are several initiatives in different disciplines, but Can we have also some inputs about the stock market in Egypt for the carbon credit?
Yes, yes, that's quite an important development. Last week, Egypt launched a carbon exchange, which is not only in Africa, it's actually focused on. Can I have the microphone? It's easier, right, because I can look at everybody. So it was working. Working. It's working. Yeah. Um, Unfortunately, the global situation on carbon exchange is extremely fragmented. We have two huge markets in Europe. We heard about the European one mentioned in the Green Deal, which is the ETS, the European Trading System for Carbon Exchange. We have an American one, which is based in California. We have another large one in South Korea and Indonesia, which is a closed one as well. So unfortunately, the markets are closed. So in the sense that if I sell their carbon credits, I will not be allowed to do that as a country or as a Egyptian business. I will not be allowed to sell my carbon credits in the exchange there. So the launch of the Egyptian one was extremely, very extremely important and forward thinking. And there are three things actually that are quite challenging for carbon exchanges to work. First is what they call transparency, which is a reflection of quality of the credits. Um, there are lots of standards around the world. That we have the gold standard. There is Vera. There's of course the mother of standards, the CDM, and there's an American one which is not applied across around outside of the United States. So the problem with the transparency part is that the organizations that were responsible for setting standards and validating the standards were not very good and they were not credible enough. So the quality of the carbon credit that was coming out in the market over the last 10 years was not credible. So that was a problem that was keeping the carbon market from growing. That's number one. Number two is liquidity, which is demand. Again, the industry all over the world. When we saw here today the CEO roundtable on decarbonization, how serious they take. I mean, companies now, global players, are actually taking the situation very, very seriously. So that's creating demand on carbon credits. So it provides liquidity into the market. But more interestingly, also on the liquidity side, that institutional investors that are not coming, that usually were investing in equities or in financial instruments in usually the traditional financing markets, are now diversifying their investments and adding carbon credits into their portfolio to hedge against climate risks, to be able to balance because they are exposed to climate risks. So, for example, if your industry does not catch up with the tax policy, taxation of carbon policy, then there is a risk there. So if an institutional investor holds assets in one of your members, and all of a sudden they find themselves exposed, so they can hedge that by investing in carbon credits. So that's also, that creates a huge demand for, and that they will come. I'm sure they will come to Egypt. The third and probably the most important is the supply. Um, in markets in Europe and in the United States, South Korea, the technology is there, the supply, the pipeline is there. We are now a newcomer to the market. Egypt alone, although we have a lot of emissions and we can potentially supply the target was 9 million tons to be traded annually in the Egyptian stock exchange. But to reach the 9 million, it will require a lot of money, a lot of time. So the fact that they included Africa, that covers that part, because we can create pipeline for a number of countries, not only Egypt, that they are traded on the Egyptian carbon exchange, that creates a supply, provided that they comply to rule number one, which is standards. Most important is that to make sure that the carbon exchange is functioning properly, that it, as it was mentioned by Dr. Farid in the launch, that we maintain a highest quality of compliance and transparency in the certification of the carbon credits. So I hope I covered the answer.
We can trade through the stock market.
Yes, anybody who can, you can do that. If provided you, if you know, I'm not trying to go leave my money and go there, but you can take my money, invest in it. If you have excess carbon credits from future after our deal is finished, you can go sell it in the market. Alternatively, you can finance yourself and then go sell the carbon credits in the market if you don't take investments from a company like ours, for example. So anybody who's willing to finance the generate or the creation of the carbon credits can sell it on the exchange, of course, in the new one exchange that will come here, provided it complies to the standard that has the, which is in a way is going to be a bit of a challenge still in the beginning, but we're pushing that. That's why we want the gold standard to come here and have a presence because you need to certify these credits to be able to sell them on the exchange. So that part can work. And there are some industries it's easy to do, and some others going to take some time. Unfortunately, farming, which is one of the most important, agriculture, one of the most important sectors in Egypt, is going to take a long time to be able to meet the standards because we fragmented small farmers all over the world. But industries like this, big scale, high know-how, good engineering, it can easily meet the standards of a gold standard and it can sell their carbon credits on the exchange.
Which entity that can qualify the carbon credits, verify and validate whatever the FRA or separate entity, third parties? We would like also to understand.
The system of standards, the three big players in the world that are gold standard, the Verra, these are the two biggest ones, and then there's the old one, the CDM, as being they have standards for every industry, and they have methodologies for inspection, validation, measurement, and so on. And they themselves accredit companies, specialized companies like Tuvnor or SGS or Bureau Veritas. These are inspection companies that have qualified and accredited. It's like an accountant, but a carbon accountant, basically. It's accredited by the gold standard or by Verra to conduct the audit of the emission reduction that actually happened. They don't have right now. They don't have a home. So we discussed when we were setting up the company, because we are licensed by FRA. We discussed with Dr. Mohammed Farid that we should create a register for these inspection, they call it VVBs, verification and validation bodies, that we need an Egyptian register for them to be listed here, so that qualified, accredited auditors are in the market. For the moment, we will rely on international ones, but very expensive ones. But he agreed, and we are going to proceed with the creation of these registers for qualified people here in Egypt. That's as far as the validation. The standards, they remain global. Because we need to want to be able to play globally, sell anywhere in the world. So we don't want them to become local standards. We want to use the globally accepted standards of verification.
Appreciate the positive messages that we get from you, Dr. Sharif, about the mechanism and the supporting financially, because, I mean, as a service provider, Qurra Energy, or the off-takers or the customer perspective as well, we are in a very bad need for such support and looking forward for the activation for such mechanism, and especially the carbon credits. This comes to my mind that is also from the service provider, Engineer Ayman. Would like to understand and get from your side how you see the potential in the market in terms of such energy efficiency applications, and to shed more light about main challenges, how to grow up in such direction, especially that we have very positive mechanism right now. So how you see the situation and in the near future?
Of course, we are very positive about the potential. Said so, there is a lot of challenges. I mean, we as a company, Qurra Energy, we have tried to localize a lot of know-how. We have demonstrated a few waste energy recovery projects, cogeneration, trigeneration, really was tough to go through, but we are determined, and we believe in our target to reduce carbon emission and to illustrate seeing is believing to really change the culture. Now, of course, of launching EG COP this morning, it was a very positive because we have to complement all elements for the success. Actually, Nuafi is a great slogan. Now Egypt is committed to replace at least 10 giga of its power by renewable. Now we heard today from Mr. Dr. Hafiz Almawi, the cheapest way is the energy efficiency. And we are specialized from the power generation side, from the supply side, which is exactly one of the, how I say, cheapest, and we can achieve this target. So no doubt that we have to cooperate together. We are looking forward for Egypt at large, government, private sector, stakeholder. We have to complement each other, authorities. Still, we have to change some of our culture to understand more, to streamline in that goal, Egyptian goal. I mean, unfortunately, a lot of time it's our procedures and policy is not in line with our goals and targets. So we have to make sure that we are all going the same direction. I was glad that EGCOM this morning is formed as a cooperation between the government and the private sector and the regulatory body. So that's proof that good example, but that example has to be enforced in different places. As Dr. Sharif said, subsidy of diesel fuel, and then you encourage custom duty free for electric cars. So those things has to be aligned in order to maximize and capitalize on our target. Anyway, I'm optimistic. I'm glad that I joined COP27 and I met so many people in the field and really give you good spirit. And you think we'll be back and we'll continue our journey. Thank you.
Thank you, Engineer Ayman. Thank you. Yes, please. Yeah.
Can I share something regarding what Engineer Ayman just said regarding actually the impact COP27 had on us? I was watching the in the first few days the heads of state speeches, and of course, because we're the host country, our president was sitting and listening to heads of states from all over the world talking about the climate challenge, and then came Al Gore. You know, he's the godfather of climate action. I don't know if you know his history. When he lost politics, he went to climate change, and he made an impact. I mean, he's really, and he has a very famous graph that shows how much emissions we're producing as human beings and how much destruction is doing to the planet. So he gave a very, very powerful speech. And I saw the camera go on President Sisi, and he was focused 1000% with what is being said. And I really think that this event here being here hosted in Egypt has changed the minds of many leaders in this country. And we will see a completely different view. Like you're talking about the mindset and awareness. I expect this will change dramatically after what happened in the last 2 weeks, honestly. So I am optimistic like you.
Okay. Before we end the session, we would like also Engineer Ahmed to hear from you about the role of Egyptian Federation of Industries and being one of the board of members and talking about awareness mindset. How can you see in a couple of minutes, please, if you please, the role of the federation that we can raise the awareness together towards such mechanism and applications?
Of course, it's now becoming very important that, as Engineer Ayman said, as everybody of my fellow speakers, it's very important that everyone from each source supports the movement towards decarbonization. We have some specialized, dedicated departments in the federation focused on decarbonization and environmental issues. As I said, as everyone knows, cement industry, steel industry, and of course oil and gas. But as far as I'm concerned, cement industry is currently really focused, and we are tackling this issue with all the governmental agencies and bodies in order. We're, of course, it's a little bit challenging. We have to raise flags in some areas where nobody is really aware of the challenges we might face very soon if we did not quickly fulfill the required regulations and get prepared for the carbon borders and credits and what might that impact the cement industry. So, but I'm quite sure, and we have to admit that multinational companies and international companies have been doing lots of work, and we are currently, as an association, really supporting and adopting their our own Egyptian roadmap towards decarbonization and net zero.
Thank you very much. I would like to thank again the audience for your time and participation. Would like to thank you, the panel, your expertise. Thank you very much for that. Yes. Please, before the end of the question, but we have I think 2 minutes. We have 2 minutes. Okay, please.
Thank you very much. This is Ahmed Gaur speaking from GASCO. Actually, I was asking about the hydrogen technology. What about the challenge of the transmission of the hydrogen? You know, GASCO is the operation and maintenance for the national grid, the national grid of the natural gas. So, if we in the future try to change it from natural gas to hydrogen, how can we transmit this hydrogen to the customers?
Actually, it's a little bit challenging. For sure, the first solution is to blend. Actually, up to 10% blending hydrogen with natural gas will not affect all equipment on the natural gas grid. It could operate as it is, and then you have 10% hydrogen being used. But pipelines designed for natural gas are not suitable to operate on hydrogen. A lot of revamping is needed. First, hydrogen causes a kind of brittleness to the pipeline, so it could be fractured. Second, seals in the natural gas. Hydrogen molecule is very small, so it could seal, it could leak out of the grid. So, revamping need a substantial revamping for an existing natural gas network. So the easiest and straightforward is blending up to 10%. You will not need to do much modification to the grid, and in that case, you just have 10% of your mix coming from hydrogen. Liquidation is very expensive because actually hydrogen is being liquidated at 20 degree absolute, which is minus 250 degree centigrade. So you need a lot of energy, and it's not that easy to be liquidated. Yes, this is a solution, but it's an energy expensive and need a special facility. The straightforward I mentioned, blending, but then building specific lines for hydrogen. This is already there. Already in Europe, there is 7,000 kilometer network for hydrogen specifically designed for hydrogen transmission or transmit hydrogen in a form of ammonia. So another approach is to convert hydrogen into ammonia and then transmit ammonia either in barrages or in pipeline. You don't need even to recover hydrogen from ammonia. Now all work is working to burn ammonia directly. as a fuel.
This is how we're going to export to Europe.
Yes, primarily, as I mentioned here, the first export approach is to export it in a form of derivative, which is ammonia or methanol. So you convert hydrogen to ammonia and methanol, and this is standard. And Egypt, by the way, is the sixth largest producer of ammonia in the world. And we already have Al Ain Sokhna, where we have an export facility for ammonia. The second approach is to use hydrogen locally, so you could transmit electricity, you generate hydrogen on the side, and then produce natural gas as a cement, and then produce export cement. So you implicitly export hydrogen within that cement. Like when we say when we import 1 ton of rice, we implicitly import 12,000 meter cube of water. So we call it virtual water. This is exactly virtual hydrogen where you export it. But in future, for sure, pipelines and facility will be available, but it's not yet close yet.
Thank you very much for your interaction and the effective insights between all parties. I'm quite sure that we have several questions, but unfortunately we have to end the session. I would like to thank you again for your participation. Thank you very much for coming. It's our pleasure, and we are very glad and proud to participate in COP27 and to have Nuwafi. It's all about the implementation. Thank you very much. Thank you very much.